Hi, I'm Paul. Welcome back to the channel. Today I'm going to be demonstrating how to perform a time-corrected gain or TCG calibration with phased array. Before we get started, I want to get something out of the way. The differences between a DAC and a TCG. Now, a DAC is a measure of how the sound attenuates as the sound path increases. The same reflector, when it's close to the probe, will of course reflect a lot of sound, and as it gets further away, it reflects less and less, which is why a DAC curve looks like a big sort of ski hill. TCG takes the DAC curve and essentially increases the amount of gain as the sound path increases to bring those reflectors up to the same level on your screen. So unless your procedure explicitly calls for you to use a DAC, especially for weld inspection, you should be using a TCG. The equipment I'm going to be using, this is a 5 MHz 32 element probe, and I'm going to use this 6 to 10 inch ERVW or extended range variable wall calibration block. This is for ASME piping welds, and I'm going to use the 23 millimeter step on the end, which is the largest one. It has 3 holes in it, and if we look on the edge of the block, it will tell us that that's T3 or thickness number 3, which is 0.906 inches or 23 millimeters. And it would be good for things like a 6-inch schedule extra strong, 8-inch schedule 140, 160 extra strong, or a 10-inch 120, 140, 160 or XXS. We need to establish the sound path range that we're going to use for calibration. Now we're using the high angles to inspect the ID of the pipe and the low angles to inspect the OD. So we need calibration points beyond those. So we need a calibration point before the ID of the pipe and after the OD. So we need to start at the 3/4 T hole and we need to go all the way through the thickness and then hit the 1/4 T hole again, which would represent just a point just past the OD. Finally, we're going to get to the good stuff and do our TCG. We're going to go into the wizard and we're going to calibrate scan 1 on an Omni scan. That would be group 1. Curve type is TCG, not a DAC. And the calibration mode is automated. You can do a manual TCG if you like. The start path and range path are the same as what I had before. The reference amplitude will be 80 plus or minus 5%. And then there's a gain setting here, and we use that just to ensure that that first reference reflector that we're using, which should be the loudest one, is at about 80%. You see here it is a little hot. So it just makes it easier if we take that down to 80% to start. And then on a VEO, you have a calibration box that spans the width of the S scan. On an Omni scan, you'd use your gates, of course. And our box start, we can move that up and down. And the box range depth is the size of the box. And the depth interval, every time we move to the next reflector, it just bumps it down by how many millimeters. In this case, I'm going to use 6. So we're going to proceed. And moving the probe back and forth through all of the angles, I'm going to run that. Now, of course, I already did a sensitivity cal at this depth, so that should be right across the screen. That's fine. And then next reflector, I'm going to bump that up a little bit to there. Okay. And then basically rinse and repeat through all of the reflectors that you're going to use for your calibration. Okay. And then double check them when you're done. And what we'll do is we'll just do all of the rest in fast forward. Now we're done our TCG. We can see that we've got our 3 hole signals lined up nicely on the first leg and into the second leg and even into the third leg. And you can also see that there is no termination echo from the end of this block, even though the holes are only about 1.5 inches from the end. And that's because the end of the block is tapered and we don't have the high angles and low angles talking to each other. Now we finished our TCG, and there's one more thing we can do. We can actually take our start and our range path and change those a little bit. This doesn't really have anything to do with the TCG, but it's a good idea to keep your file size at a reasonable level. On the S scan right now, you can see that it's starting at the OD surface or right away at the entry surface at 0. There's really no point in doing that. We're not trying to find anything right under the surface at the point in which the probe is sitting. So what we're going to do is take our start path and increase that so that it starts closer down to where we're interested. And then I can also then reduce the range path. In this case, I put 30 on at the start path, so I'm going to take 30 off at the end of the range. And here we've got a nice, almost looks like it's zoomed in. It's kind of the same effect, except that it will keep my file size down and basically makes it easier for us to see things on the fly. Basically, that's it, and I hope you found this video useful. Thanks for watching.